Today we are going to learn about installing ML libraries on Windows, best practices. This tutorial will cover the essential steps and skills needed to effectively install and manage machine learning libraries on Windows systems. Welcome to our educational video on installing machine learning libraries on Windows. In this session, we'll explore the best practices for setting up your Windows environment to ensure smooth installation and operation of popular ML libraries. With Windows being a prevalent platform for developers, understanding these practices is crucial. You'll learn how to prepare your system, troubleshoot common issues, and optimize performance for your machine learning tasks. Let's dive in and equip you with the knowledge to manage ML libraries like TensorFlow and PyTorch effectively on your Windows system.
Before installing any machine learning libraries, it's crucial to prepare your Windows system. Start by ensuring that your operating system is up to date. This involves checking for the latest Windows updates and installing them. Updating your system ensures compatibility with the latest libraries and reduces the risk of encountering errors during installation. Next, verify that you have administrative privileges, as some installations may require them. Additionally, check the system requirements of the ML libraries you plan to use. Ensure your machine meets the necessary RAM, processor, and disk space specifications. Also, install essential software like Microsoft Visual C++ Redistributable, which is often required by many ML libraries. Lastly, consider disabling any unnecessary security software or firewalls temporarily during installation, as they might block the installation processes.
Python is a fundamental tool for machine learning. To begin, download Python from the official website, ensuring you select the correct version for your needs. During installation, make sure to check the option to add Python to path. This step is crucial as it allows you to run Python commands from any command prompt window. After installation, open a command prompt and type Python version to verify the installation. If the command is not recognized, you may need to manually add Python to your path environment variable. Navigate to System Properties, click on Environment Variables, and add the path to your Python executable. This allows your system to recognize Python commands universally. Troubleshooting any path issues early on can save you from numerous headaches when installing ML libraries.
With Python installed, the next step is to use pip, Python's package manager, to install machine learning libraries. Pip simplifies the process of installing and managing packages. Begin by opening a command prompt and type pip install TensorFlow to install TensorFlow. Similarly, pip install Torch will install PyTorch. Both libraries are popular choices for machine learning tasks. Pip will automatically handle dependencies, ensuring a smooth installation process. After installation, verify the libraries by opening a Python shell and typing import TensorFlow or import Torch. If there are no errors, the installations are successful. Remember to keep your libraries up to date by periodically running pip install upgrade package name. This practice ensures you have the latest features and security patches.
Despite best efforts, installation errors can occur. Common issues include incompatible versions, missing dependencies, or conflicts with existing software. When an error arises, carefully read the error message as it often provides clues to the problem. For instance, a module not found error suggests a missing dependency. Use pip to install the missing module. If an installation fails, consider uninstalling the library using pip uninstall package name and reinstalling it with specific parameters. For example, specifying a different version, such as pip install TensorFlow == 2.4.0, can resolve compatibility issues. Keep an eye on dependency requirements, as some libraries need specific versions to function correctly. Online resources, such as Stack Overflow, can be invaluable for resolving complex issues. Engaging with community forums can also provide insights and solutions from others who have faced similar problems.
The Windows Subsystem for Linux, WSL, offers a powerful alternative for running machine learning tasks on Windows. WSL allows you to run a Linux distribution alongside Windows, providing access to a wide range of Linux tools directly from the Windows environment. To install WSL, open PowerShell as an administrator and run WSL install. This command will set up the default Linux distribution. Once installed, you can access the Linux command line by typing WSL in the command prompt. This setup provides a seamless way to install and manage ML libraries using Linux package managers like apt. Installing TensorFlow, PyTorch, and other libraries on WSL can sometimes be more straightforward due to better compatibility with Linux-based dependencies. WSL bridges the gap between Windows and Linux, offering the best of both worlds for machine learning enthusiasts. Managing library versions and dependencies is crucial for maintaining stable machine learning environments. Pip allows you to specify versions during installation, such as pip install TensorFlow == 2.4.0, ensuring compatibility with your projects. Regularly check for updates using pip list outdated to identify updated packages. To manage dependencies, consider creating a requirements.txt file that lists all necessary packages and their versions. This file can be generated using pip freeze greater than requirements.txt. When sharing projects, Others can install the exact package versions by running pip install or requirements.txt. This practice ensures that your environment is reproducible, reducing the likelihood of version conflicts. Adopting these strategies helps maintain a consistent and error-free setup, particularly when collaborating with others or deploying projects to different environments. Virtual environments are a powerful tool for managing machine learning projects on Windows. They allow you to create isolated environments for each project, preventing conflicts between library versions. To create a virtual environment, navigate to your project directory and run Python env. This command creates a new folder named env containing the isolated environment. Activate it using env/scripts/activate on Windows. Once activated, any libraries you install using pip will be confined to this environment. Deactivate the environment by typing deactivate. This setup is particularly useful when working on multiple projects that require different library versions. By encapsulating dependencies within a virtual environment, you ensure that changes in one project do not affect others, leading to a more organized and manageable development workflow. Performance optimization is key to efficiently running machine learning tasks on Windows. Begin by ensuring your hardware is capable of handling intensive computations. Leveraging GPU acceleration can significantly boost performance for libraries like TensorFlow and PyTorch. Install the appropriate GPU drivers and configure the environment to utilize them. Additionally, customize environment variables such as CUDA_home and path to point to your GPU toolkit. Monitor system resources to identify bottlenecks and consider upgrading components like RAM or storage if necessary. Tuning system settings, such as adjusting power settings to high performance, can also enhance performance. Regularly clean up unnecessary files and applications to free up system resources. By optimizing both software and hardware configurations, you can achieve faster and more efficient machine learning operations.
In conclusion, installing machine learning libraries on Windows requires careful preparation and adherence to best practices. By ensuring your system is ready, understanding how to install and manage libraries, and leveraging tools like WSL and virtual environments, you can optimize your development workflow. Troubleshooting skills will help you overcome any installation challenges, while performance optimizations ensure efficient processing of ML tasks. Continue to learn and adapt as new tools and libraries emerge. We encourage you to apply these best practices to streamline your machine learning projects on Windows. Thank you for joining us, and we wish you success in your machine learning endeavors.